Okay. Thanks everyone for coming. So today in this brown bag we are going to learn about that serverless ASP.NET Core with AWS Lambda. In this session, first of all, it's an introduction session related to that serverless ASP.NET Core with AWS. And in this session, we guys will see that how this serverless with ASP.NET Core can help a business, how efficient is for costing as well. What is the function as a service? Because when we are talking about a serverless itself a big world, and when we are going deep diving into that serverless, we have to understand about the different elements, as well as which other services are going to use with a serverless. And along with that, I'm going to show a demo that itself from your Visual Studio, without going to the console, how you can deploy your application, as well as monitor your application, as well as you can see that what log are there. Everything is from your Visual Studio. So this will be takeaway. And along with that, I will explain as well what is SAM, serverless application model, in terms of .NET Core and in an AWS. That entire architecture, that how serverless application will work with that, and ASP.NET Core architecture, and which toolings we can use for with a Visual Studio, right? So before we starting, the thing is that what is a serverless? Sure. What is a serverless? Serverless, when we are hearing this word itself, is saying that so many things, so many different things. Serverless, so many people may ask, means no server? Means what is a serverless? No need to manage a server? Yes. Thing is that when we are talking about a serverless, being a developer, you guys can focus only and only your code. Servers are get managed by AWS. It means right now in a current world, many applications and many companies are deploying their applications on AWS, but with EC2, with you know, containers and so many things. You constantly have to monitor it, constantly have to focus on that one, that okay, what's happening with that, and scaling, and so many things are happening with your deployment, and sometimes traffic goes up, how you can manage and all that. So to remove all these things, serverless comes in a picture. So when so as I told, that serverless computing allows you to build and run your application without thinking about a server. You don't need to worry about it, which OS I need to choose, or which instance size, and what I have to do that. Rather than spending a time on that, you guys can spend the time to improve your code, improve our latency as well, how we can improvise the performance, and so all those times move towards a coding, not in a server. So still your application will run on a server, but the servers will managed by AWS, and at the core, serverless computing is working with AWS Lambda, and AWS Lambda will work for you to run your application. Here you can see in this diagram, with your browser, you are not going anywhere to like a EC2 instance, and then server is talking, respective server is talking to the application. Is not like that. Here you are just directly your Lambda talking with Amazon API proxy gateway. Then CloudFormation will go to Amazon S3, and if you have a database, then your API gateway will talk to that database to pull out the data, or update the data, or delete the data. So as we start, what is the function as a service? So when we are working with a serverless, we guys have to understand about a function, because function itself giving you so many things in a serverless world. It can give you a fully scalability. All the servers are fully abstracted, and we can see that when we are using it, only that time we are paying for that one, not for that putting your application idle and all that stuff. You are not paying for that. When you are executing, at the time we are paying only for that execution. So when your Lambda will get warmed up and you are calling your it will talk to your function, and function will return data, only this trip we are paying for that. And now think about scalability. Might be in some specific time period, your traffic might goes up, so many requests comes to that particular functions or particular applications. Then how it will manage? It's auto scaling. It will manage automatically. As soon as it goes up, Lambda will pre-warmed, and it will create more request to manage that one. We no need to worry about. And you guys will surprise that Expedia is one of the leading travel site in the world. So many daily requests are coming to the Expedia. So many people across the world are using Expedia daily. So Expedia managing daily 3 million requests for a booking. Either it's a hotel, either it's a flight, either it's a car. In total, 3 million requests they are managing on a serverless, without any interruption and with performance scalability as well. So how serverless itself can help to current business or your application or your projects? When you are talking about with serverless, and first thing will comes in mind that okay, if there are no servers and I am deploying my just application and Lambda is going to do all the things, what about the security? So with security, there is a two things are there: API gateway and Lambda. So when API gateway, when we are talking about API gateway, putting your functions or putting your controller or putting your entire APIs, HTTPS is by default. Then AWS is managing OS by itself. You no need to choose about that. Okay, what you want to go for that, either Windows, either Linux, or what you want to do. And all the calls are secure with IAM or bearer token. It's reliable as well because AWS manage HA and scaling as well. Performance, yes, it's performance scalable because with serverless we can do caching as well. You can do caching, and we'll talk about the caching. It's chargeable as well, but it's not that much what we are paying for that ideal instances. Cost optimization, yes, we no need to pre-book that instances, or we no need to go for a spot pricing, or we no need to go for any scaling up or anything. It will just working with reverse proxy routes for API call, and as I told earlier that you are just only paying for your executions, not for just setting your code ideal. And the last thing is that operational excellence, because serverless application model, it's automated, and it will help us to that giving operational excellency. Now we'll see cost. Here I will give some calculation as well and example as well, that what actual cost for this serverless application execution. So first of all, for any execution, any request, any function are sub-second metering, like it's counting per 100 milliseconds. Let's say your response return in 10 milliseconds, still you will get charged for 100 milliseconds. It's 99 milliseconds, still you will charge for 100 milliseconds. It's a sub-second metering. and the number of times your code is triggered. Second, you will get charged for total number of requests across all your functions. Means function is talking with another functions, and that talking with any other services internally, and at end consolidated response are coming out, means you triggered a 3 functions. So you will get charged for that one. We are talking about basic that if someone wants to start with a free account, so serverless is AWS is promoting that every month we will get 1 million free requests for serverless. After that, only $0.20, which is the 20 cent per million request, is just a request execution. So still more calculations are in the coming up. So now we will see that with execution you can allocate your memory starting from 120 megabyte up to 1.5 GB. So as you guys write a code, then you guys will come to know that how much memory it will consume to execute that particular functions or method. So it will also comes in a picture for calculations, amount of memory, what amount of memory you are choosing. Now we will see that example. Let's take a scenario. Allocated memory is 520 megabytes, 512 megabytes. We are executing 3 million requests a month for any application. Consider internal, you are calling multiple functions. In total, we are considering 3 million times we are calling in a month. Ran for 1 second. Each time means I am talking about all the traveling time and response comes to end user. Monthly API calls charges, because API calls is a part of a service, $3.50 a million, and data transfer charge, because ultimate payloads are returning to the end user. So its data is transferred, and payload you are passing through that to get a particular request or something like that, all the transfer also gets charged as well. So 0.09 GB for 10 terabyte. As you grow up, going about 10 terabytes, price will goes down. In serverless, as you more consume, price will goes down, right? With this, let's consider in a monthly compute price, 3 million requests for 1 second, total compute seconds into memory, but memory we can divide by 1 GB. So total compute minus free tier, because here I mentioned about that we can get 1 million requests per month as a free tier. So we are just removing free tier compute and we are considering about 2 million as a paid. So in the calculation, monthly compute charge for 3 million requests is coming to the $18.34. This charge is about per execution and per compute, is not even in a sense, we can see that. Along with that, monthly request we have to make it, because compute, request, all these combinations will end up with the entire serverless application. So monthly request price, as we talked earlier, is 0.20 cents per million request. Total request minus free tier we are removing as well, and 3 million to minus 1 million, 2 million monthly billable request we are considering. So 2 million into 0.2 is equal to 0.40 for 2 million monthly request. Let's see the total. So total monthly charges, compute charges plus request charges, is comes together $18.74 per month, plus monthly API call for 3 million request, which is 10.50, and 9.66 is for data transfer charge, in terms of a memory, because how much data in size you return or you accepted. So still for 3 million requests and 3 million executions, along with all the service charges, I'm not considering right now here S3, because S3 bucket we can see that as you store or as you store your functions and how you manage, based on that it will get calculated, but it's not that much. So still it's come to that $57.64 for 3 million requests a month, which is in compared to reserving the instances, using other services, and CloudWatch, Cloud Formations, and all other services, we are paying for that. And with this calculation, you're saving up to 90% cost of your billing with serverless. So we are talking about that why Lambda. Some people are saying that is a Lambda sharp up to their naming conventions. So Lambda is using a container model. First of all, Lambda is leading in a function as a service. Continuous scaling, we no need to worry about. No servers to manage. Lambda itself caring about that one, and pay only what we execute. Let's see the model of serverless application, how entire architecture and model is working. The browser, when browser is hitting a request, what's happened actually? It will go to that URL, what URL we got from after deployment from Lambda. It will go to your specific application specific template. We'll see in the demo that application specific template, and that template will talk with different services, because everything is mentioned over there, like talk with Cloud Formation, from which bucket they have to point particular functions or particular your application execution point. And then after it will start entire journey to go to API gateway, and then it is go to the Lambda, and if there is a database, it will talk to your database. So what total number of services are getting used with AWS serverless app in a .NET Core? First of all, AWS Lambda for computing your functions or computing your application. Amazon API gateway, which is an important part when we are playing with serverless in APIs. So it's exposing to web. AWS Cloud Formations, so where you can define your AWS architect, your stack, how your stack will look like timeout, what memory you are looking for, your buckets, and all that information will goes there. S3, yes, we are storing our functions, and when you are bundling up in that serverless deployment with unique number and unique folders will get stored in S3. CloudWatch, yes, we need a CloudWatch for our metrics and dashboards to see that one, that how what's the performance and how is going on, and what's in which time it goes, like maximum usage and all these things. And last is a data transfer. So in consolidations of all the services, AWS is calculating your cost for serverless. For individual service, AWS is charging, and when we are done with that one, we can see our total amount, how much we paid for execution. What structure will look like with ASP.NET Core architecture on AWS Lambda? This might be someone already using ASP.NET Core and hosting that application on instance and all that. even running on your local. When you running on your local or any instance, you will see like that that architecture using IIS or Nginx, Kestrel and ASP.NET Core hosting. This is the entire architecture. From that point you can use users web API controller. But when we are talking about AWS, Lambda and ASP.NET Core combined together, structure will look like that. Instead of IIS and Nginx, it will replace with API gateway, and instead of Kestrel, it will change with a Lambda. This is the structure when we are deploying our ASP.NET Core application with AWS Lambda on us as a serverless. So how we can work with ASP.NET Core in a Visual Studio, and how we can deploy, and what how it will look like when API gateway will comes in a picture and when Lambda comes in a picture, and all these things we'll see. Before we start going towards that direction, AWS is providing a toolkit for Visual Studio. With that toolkit, you can do lots of things. Usually what you are doing with login to the console. So here is the benefit is that every time you no need to switch towards the console when you are developing or deploying, or check your CloudFormation stacks, check your S3 buckets are exist or not, what's in your S3 buckets, what even for logs you don't need to move on the console. This tool itself providing your support, and it's really lightweight and it's performing well with Visual Studio. You can get this tool from AWS site, just aws.amazon.com from /Visual Studio, and this kit is available for VS 2015 and 2017 as well, and also supporting for legacy versions 2008, 2010 and all. As soon as you install this tool and open your Visual Studio, it's open with this start page. It will look like this. So here you have to set up your credentials. You can get from your IAM. Set up just your profile name. You can put your profile either is a QA or SIT environment, pre-prod, prod, or learning or whatever. So when you deploying your particular applications, you can choose that way on which profile. So it will take that credentials and it will work along with that and show you that particular services. Access keys, secrets, and account number. Either you can import from CSV as well. As soon as you saved your profile and credential setup, you will see this AWS Explorer in your Visual Studio. With that AWS Explorer, you can see so many services, and you can pick particular region, which region you want to see your services and other things. CloudFront, DynamoDB, EC2, RDS, S3, SimpleDB, SNS, SQS, everything is available with the AWS Explorer, and we can play around with that one. So with this, let's see one demo, small demo, and how it gets deployed. Here I created a one ASP.NET Core API application with Lambda. As soon as you install this tool, and let me just as soon as you install that tool and you create a new project, you can see that option, ASP.NET Core Serverless application, and you can select a sample project, or there is another project which calling with a DynamoDB and blog. It is giving a sample, but this is a empty application where I wrote my custom controller, and we'll see that. But as soon as you create a new project, you will see that we'll get a Lambda entry point. This file usually we are not seeing when we are creating just .NET Core application, .NET Core API, and this is adding by with help of that toolkit. And as we talk about, we already discussed in that architecture API gateway and Lambda with .NET Core architecture. So this is a entry point when is executing from Lambda and is using a API gateway. And along with that, we'll get a serverless template which you can consider as your CloudFormation. Here you are preparing your stack and putting your informations. Nothing much to do over here. You have to just choose your memory size and timeout, because the rest of the things you already define in your profile setup. What Lambda needs, just memory size and timeout to execute your function and execute your controller. That's it. We are done with once we guys are done with that, and just a sample controller which is written only hello. Now everything is ready, working fine. You want to deploy. Usually what we are doing, we are going for any build pipeline tool or somewhere just committing and then it's deploying, right? But with this, right click, you can just deploy out to AWS Lambda. On AWS, it will display this wizard. Here you have to choose your stack name. Here is my stack name. If you are doing first time, you have to create a new bucket, else you can choose your existing bucket, which region you want to, and here you can select a profiles, because might be different profile per different accounts or different environments you can choose. And as soon as you done with all the requirements, and just click on a publish. Less than a minute time, this application will publish to that and it's ready to use. It's just bundling up. As soon as bundling up, it will show the CloudFormation, what's happening right now, in which state right now. It will open the CloudFormation wizard as well. See, here you can see previous stack events as well, and right now it's update in progress. Main thing is that as soon as you are publishing and your old functions are already on S3 bucket, it won't get disturbed until update is complete. All your users are still able to use that previous function, and update complete, as soon as they are hitting again or refreshing, they will start getting using new changes or new functions. Means here serverless also helping you with this deployment, kind of a zero downtime. You are not disturbing your users, still they are working that, and as soon as you are done, user are start getting your features or new changes, and we don't need to worry about that what's happened and just swap the environment or anything. Okay, as soon as the update will done, it will give you a URL. Here you can make your custom URL with your domain as well, particular application domain or subdomain or whatever. But if you don't have anything, if you didn't set in Route 53 or if you didn't link up, it will give you this random URL. This URL will say remain as it is after a first time, because first time you deployed, it will give you a URL, and then after you are just updating and changes, it will remain as it is. Yep, our code is deployed. Let's check. Yes. First of all, it is Very first time it will take time because here Lambda is getting warmed up. So first time it took to it to 7 millisecond. Next time you can see that, and all the requests are measuring on sub-second some sub-second metering. Now it's in a 2-digit. It varies between 55, 84, and all that. So 100 millisecond it will get account for your billing and execution. Okay. Apart from that, here we have seen that what's happening, but if you want to see particular logs, what's happening with that, we can go to the AWS Explorer, refresh AWS Lambda, and here we can see that function. We came here to see this function. Why? Because we executed a couple of requests. We want to see that how much time it took. Sometimes it's returning a 404 because of request is not valid, or 200 what's the request status and how much time it took, and all these things is get logged. We can see from here. You can see stream name, first event, last event, and when it's executed. For entire execution time, and as soon as you are deploying, keep deploying new version, it will get stack up. So even I'm executing this for 2 days, the log will get piled up. You can get a log file. And here it will show that what's happened. So durations, build duration, how much memory and maximum memory is used. You can change your memories as well, because okay, now we don't need to worry about the servers. So we have seen that okay, for just this small bit or these things, it's taking this much memory to return a response. Can work on that and can be more optimized. It will consume less memory, might be a faster data request transferring as well, and you can optimize your payloads and response as well. What required for that consumer, you can return only those things, and it might be if talking with a database, we can optimize that database queries or store procedure, whatever is that. And main focus is that with this regards, ultimate it will help us to better write a better performance for code. So, and as soon as you guys will see that, okay, if you want to upload a new source, you can upload from many places, not only just publish from that one. You can see your function as well, where is get stored. If you are going to the S3, in bucket, you can see everything. Means main focus will stay as it is. You are not going to the console, you are not checking so much things, fast as well, deploying as well. And if you want to implement this one in the CI/CD pipeline, just one command line will help you to that packaging your stuff and deploying on S3. Rest of the stuff, when as soon as you are executing your Lambda, it will be there. And you can explore more with this tool, with this performance. And if you have two application talking with each other and both are on serverless, you can give reference to each other, as well as if one is on a EC2 instance and one is a serverless, still they are talking with each other. So whatever time will take to talk with all the application and consolidation, it will just your execution time. And you are not executing for 2 days, no worries, you are not paying for that. So that's it. Any question?
How long does it take before you need to go through a warm up again? What's the idle period before it spools down?
So first time you are executing like your request. Depends on your entry point executions, because this is called as a latency until it gets warmed up. Usually you can consider between 1000 to 2000 milliseconds very first time, because Lambda was down and no one just hitting that one. But as soon as get warmed up with the first request, then you can see it's returning very fast. But in between 1000 to 2000 milliseconds first time.
Is that after that scale out doesn't have that same?
Yeah.
And then like I guess overnight it'll scale down again.
Scale down again.
But are there any kind of metrics around when it scales down? Like
yeah.
If there's an hour of an activity or?
Yeah, from dashboards you can see that particular time period or that we have to create that dashboard based on requirement to see that what's happening over particular time, and we can see that okay, in the nights it's down, but somehow on well, let's consider about this MYOB application, one of the example in the March or July period is going lots of usage, and you can see that okay, particular 10 to 2 o'clock, morning 10 to afternoon 2 is going up, and based on that you can measure and you can check that one. And with that same timing you can check your logs as well, and you can see that how much memory was consumed and new Lambda will warmed up and how much is consuming a memory as well.
It also supports Core 2.0, or is it only on Core 1?
Right now Core 1 at the moment for with inbuilt toolkit, they are in they have a roadmap to move towards a 2.0. But without this toolkit, if you want to go with ASP.NET Core and Serverless Lambda, is supporting 2.0. Yeah.
I think they have moved over to 2.0.
They moved, but this toolkit is still, yeah.
With the toolkit, I think I tried it yesterday and I was able to create.
This is just 1 week before I installed, because last year I know that they were using only 1.0.
Yeah, but I think
We can see that one.
Speaking of the toolkit, does support remote debugging at all?
Debugging kind of like?
Well, in IIS you can actually attach to an IIS instance and debug.
Yes. Yes.
So you do that with, is the access the same?
If if you want to debug at your local, you can just do as your simple IIS self-host. You can debug as well, and when it's on a server, you can deploy as a debug mode, and it will give you more details regarding that one.
Any other questions?
So you said cold start is basically around 2 seconds. So if I'm not mistaken, Lambda takes like 5 minutes, and every 5 minutes is going down. So
Depends on your traffic.
It depends on your traffic.
Yes.
But it depends on exactly how big is your function. So my question is, how big is your function? What's your plan about? Do you make small functions and each function is called another functions like in a chain? Or it's like you put all logic in one big function?
So actually,
it's like a API normal one.
yes. So actually serverless concepts came with microservices. So if your function is containing too much stuff and doing like a monolithic and executing in just everything is in just one function, it's better to split it down into that particular requirement or logic, and those functions will talk to each other. So means you have let's say four functions are talking with each other. It might be faster, because as soon as you are talking with all four, Lambda is warmed up, and you are calling them, and it will help you down to performance as well and billing as well. Two things.
So basically it's gonna stack, right?
Yeah.
So first function 2 seconds, that function gonna call another function, it's another 2 seconds, so it's become like 4 seconds.
First time, yeah.
First time.
Yep. Because as first function called to second function, it will warmed up, the third function and fourth function warmed up, and now you are hitting again. So all these are warmed up, and you are calling and getting a response back.
Okay. So is it fine for your company? Like when the first request, if you're gonna experience
Even in right now, if let me talk about my where I'm working my application. Usually there is a latency time is between 3 to 4 seconds, right? We are monitoring that dashboard as well. In compared to that one, here we are getting little bit faster, but we can improve that one as well. And pre-warm up Lambda, because you have to you can do many multiple ways. You can pre-warm your Lambda, so it will give you a fast response. So there won't be any like that waiting period like 2 seconds or so, because Lambda is already warmed up, and you can get a response instantly with your execution.
What options are there for being able to run your Lambda locally on your computer?
What options there with this toolkit? I'm not sure what options they are providing to run Lambda on your local machine. So right now, and there is no any other options as well with this toolkit to run locally.
Have you tried core instead of C# and core something like Node? What is the speed comparison in terms of loading stuff?
Okay, with this Node and .NET Core, Node is not using this toolkit to like giving you all the performance and all the actions, but yes, again it's a Lambda, and both technologies are in there for serverless. In terms of latency period, again it's depend on how we write a code. If you write fat code in even Node, and good structured code in a .NET Core, obviously you can see performance over there. But same other way, you have fat code over there, and in Node you have more scalable code. You can get performance response better in the Node. Everything with the serverless is not about a technology or a language. It's about how we optimize our code to get a response better, fast.
I've done some reading on like synthetic benchmarks on these, and it seems that .NET Core is actually the fastest for like-to-like benchmarks at the moment. Generally have the smallest function sizes, and just because most of the stuff's already pre-baked into the infrastructure, and yeah, .NET Core is blazingly fast at the moment. So it's like Java and .NET Core like
racing to each other. But again, in Node with a REST API, if you are going with a REST API in a Node, and if you have well optimized, you won't face that much difference between a .NET Core and Node response. But again, it depends on how you structured your code well.
Yeah, that's what I actually kind of wonder, because if you do it in Node, you make a package JSON or something, so every time you start, it's going to download all the packages.
Yep.
So that's again make it very slow. So in the core, we don't have this problem, right?
Because you have when you Lambda will take care for that one.
So basically, in the core project,
NuGet package, we in a .NET is a NuGet package is there, right? So Lambda will take care that when you execute, and all the dependencies what you required. It's the same. .NET Core also there is a dependency based on your project, right? What you are having in the Node and .NET Core.
I think that's all we have time for.
Okay,
Any
no worries. Thank you.
Our next brown bag is on Thursday next week. Amanda will be talking about her journey from development boot camp to full-time developer job.
Thank you.